then it is optically active. Then it will have two forms, enantiomeric pair. One is maybe dextro, then the other mirror image becomes levo. If it is equal in quantity, 50% of this, 50% of this, both got mixed, then it is called racemic mixture. Again, racemic mixture is optically inactive due to external compensation. Here I call it as internal compensation. Due to internal compensation, it is optically inactive. Optical activity doesn't exist. That is the meaning of it. Done? Okay, wow.
Sir, after this, you told one point, sir.
Oh, tartaric acid. Maybe you are asking about this one.
Yes, sir.
COOH, COOH. Now total carbons are 4, right? Now it is also having plane of symmetry or not? Can I cut this into 2 equal halves? So we call it as mesotartaric acid. TAR. Okay. Mesotartaric acid. This is called mesoaldaric acid. Done?
Yes, sir.
Next one. Arabinos. Where we have seen these arabinos? Pentose. Glyceraldehyde. Below that glyceraldehyde, 2 tetroses. Erythros, trios. Below that, 4 pentoses. What are they? Ribose, arabinos, xylose, lyxose. Yes or no? Now what they are saying? Arabinos. Arabinos means pentose. So 5 carbons should be there. So do all have 5 carbons or not? All have 5 carbons. Right? They are saying plus arabinos is 2R, 3S, 4S. Now, it is an aldopentose. Which of the following is that? Which among the following is that? If you know that table, it is fraction of second question. If you don't know the table, we need to solve it. How to solve that? Second configuration is R, third is S, 4 is S. Right? This is first carbon. Here I cannot write. Answer is 2R, 4R. Okay, this is first carbon, second, third, fourth, fifth. So they are talking about second carbon, third carbon, fourth carbon. These 4 are chiral. Now I need to give priority order. Follow CIP rules, Kohn, Ingold, Prelog rules. Right? So which is the first priority carbon? Priority atom 1. Next priority, carbon connected to oxygen and carbon. But this carbon connected to oxygen with a double bond means I need to consider it as duplication, 2 oxygens. So this is priority 2. This is priority 3. This is priority 4. Now what is that direction? 1, 2, 3. Is it clockwise or anti-clockwise? That priority order. Anti-clockwise. Anti-clockwise means yes. If hydrogen is horizontal, reverse. We call it as golden rule. Right? So what is the configuration? R. Any questions in that? Based upon priority order, if I have 1 here, 2 here, 3 here, 4 here. Now, what I have to do? 1, 2, 3. What is it? Clockwise or anti-clockwise? This one. Clockwise. Clockwise means R. But least priority atom is horizontal. Then I have to take reverse of it. Then I will take it as S configuration. We call it as golden rule. Right? Now, second carbonate is R. Now, what about third carbon? 1. Carbon, carbon. Carbon connected to oxygen, carbon. Carbon connected to oxygen, carbon. That carbon connected to 1 oxygen, but this carbon connected to 2 oxygen. So priority will be above carbon will be higher priority. So 1, 2, 3. So 1, 2, 3. What is it? Anti-clockwise, hydrogen horizontal. So R, no need to check because there I should get yes. Now, based upon this should be R and this becomes yes. Correct or not? Based upon this. If I write OH this side, definitely it becomes yes. Correct? Means this becomes again R, yes. This becomes yes, R. Correct? Now I will check for the third one. Now what they are saying? First priority will be oxygen, so 1. Second priority, carbon connected to oxygen and hydrogens. Here carbon connected to carbon and oxygen. So second priority will be this. This is third priority. This is fourth priority. Now I am connecting. What is it? Clockwise or anti-clockwise? Clockwise. Clockwise means R. Hydrogen horizontal. Clockwise means R. Hydrogen horizontal means reverse. Right? So it should be. Yes. For clockwise, R. For anti-clockwise, yes. If hydrogen is vertical, as it is. If hydrogen is horizontal, reverse. Right? So which is correct? They are saying R, yes. If it is yes, this is also yes. Correct? Then this becomes R. This becomes R. Now which is correct? R, yes, yes. Which is correct? Oh, correct. Clear? Right? Now, if you see the table, we wrote first D-glyceraldehyde, if you remember. Correct? Huh? In the D-glyceraldehyde, we wrote CHO, CH2OH, HOH. We fixed the position of this OH in all the cases, correct? And we keep on introducing next carbon, and so on. When I separated that into 2, what we got? Erythros, trios. In case of erythros, both OH should be same side. Correct? Huh? Response, sir. From erythros, again I brought 2. So what I have done? One more OH I kept. And here, response, whether I have taken this one or not. Right? This is ribose and this is arabinose. So in case of arabinose, what should happen? What should happen? Right? 2 OH groups are on one side and aldehyde below OH group must be in another side. So which among the following is suitable for it? Whether this option is suitable for it or not. And this option is also suitable for it or not. Correct? So answer should be either 2 or 4. Correct? Now, plus or minus they gave. Plus or minus cannot be found theoretically. They have to find experimentally. If they give D, then I might have gone answer as 4. They have not mentioned a D form or L form. If they have mentioned a D form, then I will go for this one. If they give L form, what I will do for L form? This will be reversal. Correct or not? Means this is a D form of it and this is L form of it. Yes or no? So what they are questioning in this about? They are asking about L form of arabinose. Correct or not? Because they gave 2R, 3S, 4S, right? Whether it is R correct or not? 1, 2, 3. 1, 2, 3. Anti-clockwise, right? Anti-clockwise means yes, but hydrogen horizontal. So R. So correct only. If that is correct, remaining all will go well. Clear? Online. Now, glucose when reacted with acidic anhydride forms Pentaacetate, hexaacetate, pentaacetate, right? Mutarotation in aqueous solution is shown by, which shows mutarotation. To show mutarotation, what should be free? Hemiacetal OH. That OH should be free. In which of these four that OH will be free? Not in sucrose, not in cellulose. Answer is maltose. Over. Maltose is the answer. Are you able to understand? In that way, can you solve all these questions? Question number 19, sir. Glucose does not give Gibbs test. Para-rosanline anhydride means hydrochloride by passing SO2. Answer is all of these. We have seen this question as it is. Respond. Any questions? Question number 11. Glucose does not react with sodium bisulfate.
Option
3. Correct? Huh? Respond. Correct or not? Right? What about option 1? First it will react. Correct? Correct or not? And so on. All these are same things. So 21 questions are there. Can you solve? Easy only, no? Not so difficult. So that's why I keep on saying, listen to the class carefully. That is enough. And simultaneously, immediately, if you solve the questions, open. Right? Now I am going for next part, sir. Proteins. Okay? Shall I, or you need to? I need to solve few more questions. Shall I start proteins topic? Respond.
Sir, can you solve few more questions?
Few more. Question number 9. Anomers. Right. Question number 10. Question number 10. Cyanohydrin. Correct. Question number 11. Just now done. Question number 12. Starch is a polymer of alpha glucose. Amylose is a component of cellulose. Proteins are composed of only one type of amino acids. In cyclic structure of pyranose, there are 5 carbons and no oxygen atom. So which is correct? Huh? What one correct? What about first option? Starch is a polymer of alpha glucose units. Correct. Amylose is a component of cellulose. No, it is a component of starch. Proteins composed of many amino acids in different sequences. Correct?
Only one type of.
They are saying only one type of amino acid. Proteins have many types. 20 amino acids, they can be arranged in different ways. No? All are alpha only. All are alpha only. But 20 types of alpha amino acids are there. Not only one type of amino acid. Correct? Understood or not? Right. In cyclic structure of pyranose, there are 5 carbon atoms and no. They are saying pyranose, no? 5 carbons and 1 oxygen. Total put together 6. Correct? 13, sir. Fructose reduces Tollens reagent. Why? Presence of ketone group, presence of NH4OH in Tollens reagent, rearrangement of fructose into a mixture of glucose, fructose, and mannose. That's why it behaves as reducing. Why fructose will reduce Tollens reagent? We know that due to presence of heavy acetal group at second carbon. Right? Correct or not? So, due to that heavy acetal group, it is showing reduction, means it is a reducing sugar. Now, what they are asking, whether it is because of ketone group, and Tollens reagent will be positive because of keto group or alpha hydroxy keto group. Ketones are not allowed to react. No, they will not give positive test with valence. Alpha hydroxy ketones, alpha hydroxy carboxylic acid is used positive test. So if they mention presence of keto group with alpha hydroxy, then option 1 is correct. Now I cannot say option 1 is correct. Now second option, due to presence of ammonium hydroxide in valence reagent. Do it reacts because of ammonium hydroxide in valence reagent? Or due to presence of OH group in fructose? Due to presence of hemiacetal group or due to presence of ammonia in valence reagent? Why it shows positive? Right? Hemiacetal group means option 2 is ruled out. Now option 3. It can rearrange to form a mixture of glucose, fructose and mannose. Yes. It will be rearranged. Why it is getting rearranged? Due to presence of base. Are you able to understand? It can be rearranged. Already we discussed now. What is that rearrangement? Eckernstein rearrangement. In basic medium, it will interconvert to glucose and mannose. You are providing basic medium. That's why it will rearrange. When it gets rearranged, obviously it shows positive test with valence reagent. Yes? Correct or not? So can I go for both 2 and 3? Right? I am not much convinced with 2 and 3. I am convinced with 3. Because the 2 is correct if it is accompanied with 3. Otherwise, 2 is not correct. Are you able to understand? This is correct only, no doubt. But this will not give. Because of this option 2, tolerance test will not be positive. Because of option 3 will happen due to base. So I am convinced with option 3. I once check, do you have any answer key? If you check once. Oh, you don't have the key, huh? Where I can find the key? If you have target booklet. Okay, if you have, just to find it, sir.
Sir, answer is 4, sir.
Both they have given a.
Yes, sir.
Hey, Pakka.
Yes, sir. I saw the solution, sir.
Solution, huh? Okay. So they gave answer as option 4, but 2 is correct if and only if it is accompanied with 3. If a 3 is not there, 2 doesn't have any meaning. Correct or not? Response, sir. Okay then. Next one, sir. Question number 14. Which of the following is correct about cellulose? Cellulose, important food material for animals, or we can say which can have cellulose enzyme or emulsin enzyme. Otherwise, it is not a food source. It has only alpha glycosidic linkages. Only beta. It is sweet in taste. All polysaccharides are non-sugars. Right? Correct or not? So answer is third option. Acid hydrolysis of sucrose causes inversion. We call it as inversion of cane sugar. Initially, what is sucrose optical rotation? Plus 62. Correct? 66, 66.5. Then finally it converts into plus 52.5 and minus 92. Per mole, it becomes minus 21. Right? So positive converted to negative. That's why it is called inversion. Correct or not? For glucose 1 mole, fructose 1 mole. Fructose 1 mole is minus 92. Glucose 1 mole is plus 52. On an average, minus 40 for 2 moles. So per mole, minus 20. That's what I am saying. Right? Glycosidic linkage is present in carbohydrates. All questions we are done. Which of the following disaccharide is called invert sugar? Invert sugar. Oh, they are saying disaccharide is an invert sugar. Only sucrose, right? Because on hydrolysis, right? Inversion. Maltose, both are alpha forms only. Lactose also both are, no. In case of lactose, one is beta, one is alpha. So that we cannot say. Right. Then only is sucrose. Branched chain structure is shown by amylopectin. Glucose does already over. Cellulose is soluble in what? No. Organic solvents maybe, but if it is soluble in organic solvents, it will decompose. So I think ammonical cupric hydroxide solution. Answer must be option 3. Alright, once any one of you please check this.
Option 3, sir.
Option 3. Ammonical cupric hydroxide. Ammonical silver hydroxide is toluenes. This is ammonical cupric hydroxide solution. Same ammonical cupric hydroxide solution we will discuss in one case. For idiometry. Ammonical cuprous chloride to detect carbon monoxide. What's that? For identifying carbon monoxide, we use ammonical cuprous chloride solution. Right? Okay. They should make it as note down this point. One more point. We missed this point in class. Right? Cellulose is soluble. Better, I will write that also. While we are discussing cellulose, we missed this point. Here. Cellulose is soluble in. Here I am writing. It is soluble in ammonical cuprous. Cuprica, cuprasa. Cupric means CuOH twice. Over. Then cane sugar on hydrolysis gives waste question again. Cane sugar. Glucose plus fructose. Over. Done. Now shall I start? Proteins part. Biomolecules. Very easy, sir. I am saying again. For 100% sure, you will find one question in JEE mains, one in advanced. NEET also you will find minimum one question in chemistry, one question you will find in botany or zoology, right? So for sure you will get 2 questions in NEET paper from biomolecules, right? Damn easy, sir. It was stuck. Just a moment. It got stuck. I'm closing this, huh? Let me reopen. Again, I am saying, sir, at least today, after going home, revise it once. Revise it once. And you have coming test. For your FT, you have biomolecules, huh? No. AITS plus. Second AITS plus, you have biomolecules chapter. I think second AITS. Second AITS, you have alkyl and aryl halides, alcohol phenols ethers, aldehydes and ketones, amines, biomolecules, carboxylic acids. Right? Now, sir. In JEE, along with biomolecules, you will find online. All are online exams. They have to bring the devices and they will write the exam here. So in case of vitamins, sir, you need to remember all those amino acids. It is must for you to remember amino acids and their structures. Right? In zoology also, it is very important. Yes or no? almost in every NEET paper, either they will give one question related to amino acids in chemistry or in zoology. If you want, check after going home, check that previous NEET papers, right? For sure, you will find one question. So, just a moment. Oh, not opened. Wait, it is not opening. Desktop. Again, let me reopen NCRT biomolecules. Oh, it is not opening. Ah, right. Okay. Every point from your NCRT, I have read every point, right? Now we are discussing about this proteins part. In this, you must be thorough with this table, right? Glycine, alanine, valine, lysine, isoleucine, leucine, isoleucine, arginine, lysine, glutamic acid, aspartic acid, glutamine, asparagine, threonine, serine, cysteine, methionine, phenylalanine, tyrosine, tryptophan, histidine, proline. These are 20 amino acids. They are classified into essential, non-essential. So I will do one thing. We will try to remember them by using one mnemonic, right? What is it? Yesterday we discussed it. What is it? I, instead of love, I will write like. I like Lucy very much. Please help me out. Please try to help me. Try to help me. For all these things, love, like, one enzyme and one vitamin is necessary for us. That is, deficiency of arginine will lead to something else. We don't discuss that. Okay. So this is very, very important amino acid. So here this I represents isoleucine. Isoleucine. And here it is lysine, leucine, valine, this one methionine, phenylalanine, tryptophan, this is successful. Okay. Tryptophan, yes, threonine, histidine, and arginine. Histidine and arginine are considered as semi-essential. Right? What are essential and what are non-essential amino acids means? Essential amino acids are must have to be taken through diet. Right? So can I write them as here I am writing essential amino acids. Right, sir. Now, these vitamins connect to each other to form long chain polymers. We call those polymers as proteins. So what are proteins means? Polymers of amino acids. Example, now any protein possessing food materials. All protein possessing food materials are milk products, right? Cheese, butter, and so on. Pulses, peanuts, right? Then meat, fish, etc. Now, these amino acids are classified into different types based upon the position of amine group and carboxylic acid. If they are present on alpha carbon, we call them as alpha amino acids, or beta, or gamma, or delta, etc. But here our study is majorly about alpha amino acids, right? For example, if you have carboxylic acid, COOH, bond CH2, again bond CHNH2, then what I call it as? This is carboxylic acid, priority functional group. Then this is alpha carbon, this is beta carbon. Then what I call it as? Beta amino acid. If it is on first carbon, if NH2 is present on this is alpha carbon, then they are called as alpha amino acids, right? So in our body, we have only alpha amino acids, right? So our study is only about alpha amino acids, right? We call protein if and only if this on hydrolysis gives alpha amino acids. Instead of alpha, if it is giving either beta or gamma, any other amino acid, I don't call it as protein. Proteins means they should be formed through only alpha amino acids, right? That's why proteins on hydrolysis, TEI or TIE? TIE, okay. TEI or TIE? TEI, okay. Proteins on hydrolysis should give only alpha amino acids. Then only I call it as protein, right? The names of these amino acids all are common names, means based upon the source, those names of amino acids are given. For example, glycine. This amino acid glycine is obtained from glycose. Glycose means, why it is called glucose? Sweet in taste, right? Because glycose means sweet. That's why it is called glycine. Tyrosine. Tyros means cheese. And so on. So names of these amino acids are based upon the source, right? Next, sir. These amino acids are classified into different types based upon different parameters. All these amino acids are colorless. They are all colorless, crystalline solids, colorless, crystalline solids means they behave like salts, correct or not? Colorless crystalline solids means they are behaving like salts. They are behaving like salts means they are soluble in water or not? So all amino acids are water soluble. They are classified into different types based upon the functional group. First classification is based upon functional group is present. Now see this. If you have one carboxylic acid, one NH2 group. One carboxylic acid means acidic. One NH2 means basic. Overall, it becomes neutral. If you have an extra carboxylic acid group, then it is acidic. One extra NH2 group, basic. Both are equal in number. Neutral, right? So based upon the functional groups present, it is classified into three types: acidic, neutral, basic. Acidic, neutral, basic. Basic means that amino acids will have extra NH2 groups. Acidic means extra COH groups. Neutral means normal, right? Next. Second classification is based upon their availability. Second classification is based upon their availability. If they are available and must be taken through diet, they are less available but synthesized by body, right? Availability in nature. See this, see the beauty of creation. Whichever amino acids are less available in nature, body will create them. Which are available in nature, which you can take through food, body will not create them. Maybe during our evolution process, maybe it happened, or its creation, right? So essential amino acids, non-essential amino acids. Essential amino acids must be taken through diet. Non-essential amino acids, they can be synthesized by body. Do you have any questions in this? While we are discussing about carbohydrates, all carbohydrates are T forms, right? Naturally occurs. All amino acids are L forms. So next point. All amino acids are L forms. So which is taken as reference for amino acids? L-serine. For carbohydrates, which is taken as reference? D-glyceraldehyde. So here L-serine is taken as reference. Right? Serine means same, take glyceraldehyde, instead of OH, place NH2 group, right? So COH I am taking, carbon, CH2OH. If I take aldehyde, CH2OH, HOH, glyceraldehyde, right? Now I am taking NH2 and H. Correct or not? If this is group is towards left side, then what we call it as L form, right? Is it chiral carbon or not? And I call this as alpha, this as beta, correct? Huh? This is priority functional group, right? So can I call this as alpha amino acid or not? Is it alpha amino acid or not? And we call this as L form, and this is nothing but L serine, right? Now, all amino acids are L forms means in all cases, what should be there? In all cases, on second carbon, NH2 must be towards left, right? This is fixed. This group is fixed. For all amino acids, this position is fixed. Only difference is the next chain. You will find the difference in next chain, right? This position is fixed. Only the difference is next chain. If a next chain is having CH2OH group, then it is serine. If this is H, then it is glycine, right? So we are mentioning this as R. Now we are talking about this R group. We are talking only about this R group. If this R group is hydrogen, if this R is hydrogen, then it is called glycine. GLY. Right? 3-letter symbol. 1-letter symbol is G. Right? 1-letter symbol for glycine is G. 3-letter symbol is GLY. Or simply we write as glycine. Right? This is the only optically inactive amino acid. Remaining all amino acids are optically active, because if you take hydrogen, whether this carbon becomes chiral or not chiral. Or if I take another hydrogen here, then it is not chiral. So it is optically inactive. So among amino acids, only one optically inactive amino acid is glycine. Now, if this is methyl group, if it is methyl group, CH3, right? Then it is what? Alanine. 3-letter symbol, ALA. 1-letter symbol, capital A. Right? If a methyl group is there. Now, if we have isopropyl group, what is isopropyl group? From last carbon, second carbon should possess CH3, right? From last carbon, second carbon should possess CH3 group. If this is that chain, if this is that alkyl chain, can I call it as isopropyl substituent? This R is isopropyl. If it is isopropyl, observe the difference, sir. If we have propyl, it is different. If we have isopropyl, it is different. Right? Sorry. Isobutyl and secondary butyl. So if it is isopropyl, we call it as valine. VAL. Single letter is V. Isobutyl chain. Isobutyl chain. Isobutyl means totally how many carbons? 4 carbons. But second carbon should possess methyl group. This is isobutyl. If it is isobutyl chain, then it is leucine. LEU. Single letter is L. Now, secondary butyl, sir. Observe, sir. Isobutyl is leucine. Isobutyl is leucine. Secondary butyl is isoleucine. Observe the words iso. Right? So if it is secondary butyl, CH3, CH2, CH, CH3 bond. Secondary butyl chain. Then it is called isoleucine. ILE, isoleucine. Capital I is the single letter symbol. So secondary butyl is the substituent. Right? So till now, how many over? This is 1, 2, 3, 4, 5. Right? Now observe, sir. 6th and 7th. You remember these two as one group. 6th amino acid and 7th amino acid. You consider them as one group. Why? Observe the structures. NH double bond means imine. N double bond NH. Double bond NH means imine group. Right? NH2 group. Amine group. Again NH. CH2, CH2, CH2 means you have extra NH2 groups or not? Extra amine groups or not? Response, sir. Right? So 3-membered carbon chain followed by NH, C double bond NH, NH2. It has a secondary amine group, a primary amine group, and an imine group. 3 different groups are present. Right? Secondary amine is there, primary amine is there. Already one NH2 is present here. Right? So 2 primary amine groups and 1 imine group. So definitely it is basic in nature. Right? Name is arginine. Arginine. Symbol ARG. Single letter R. Observe carefully, sir. Arginine. Most pronouncing word is R. That's why single letter symbol is R. Right? Next one. Sir, yes, sir. Hmm. Yes, sir. Unable to get. Yes, sir. You can take. You can take. You can take the list. Already I conveyed to Prasanna madam also. Okay, okay. Okay, okay, okay. Carry on, carry on. No issue, no issue. No issue. No issue, sir. No issues. Yeah, no issue, sir. Okay, sir. Right, sir. Okay, right, sir. So these two are basic amino acids. Observe, sir. 4-membered carbon chain with NH2 group. 3-membered carbon chain with NHC means it both have 4 number of carbons. Do both have same number of carbons or not? So number of carbons remains same. It have only one extra primary amine. It has a primary amine, secondary amine, amine. Arginine, lysine. Basic. Now 8 and 9. Remember them as one more group. These two as one group. 8th and 9th. You consider them as another group. Glutamic acid, aspartic acid. Glutamic acid, aspartic acid. GLU, single letter symbol is E. Aspartic acid, ASP, single letter symbol is D. Both are acidic. Observe the name. Glutamic acid, aspartic acid. Both are acidic, means they possess another extra CH2 means a COH group. So observe, sir, aspartic acid. CH2COOH. This is CH2CH2COOH. So glutamic acid have more carbons than aspartic acid. Both are acidic. Glutamic acid, aspartic acid. Any questions in this? Any questions in it? Now, instead of acid group, if I write amide group, in glutamic acid, if you write amide, right? In aspartic acid, write amide group. Glutamine, asparagine. Glutamic acid, aspartic acid. Glutamine, asparagine. So 10 and 11, write them as one more group. 10 and 11. Glutamine, asparagine. Glutamine, asparagine. So glutamic acid symbol is GLU. Glutamine symbol is GLN. Right? Single letter Q. This one is ASN. Single letter N. Both are amide linkages. Both are amide group possessing amino acids. NH2 extra NH2 group possessing amino acids, extra COH group possessing amino acids, amide possessing amino acids. So what is glutamine? You can see it directly now by looking at it. CH2, CH2, CONH2 group should be there. Asparagine, CH2, CONH2. That's all. Response, sir. Any questions in this? Now, 12 and 13, remember as another group. 12 and 13. These two are alcohol group possessing amino acids. One is threonine. Already you know one more one. Serine. Threonine, serine. Single letter symbol for serine. SER, threonine. THR-T. Serine, threonine. Now, same like above. Serine is CH2OH. Threonine, one more carbon extra. CH3, CHOH. Now see this. Serine has primary alcohol. Threonine is having secondary alcohol. Right? It is having primary alcohol group. Threonine is having secondary alcohol group. Right? Next one. Sulfur possessing. These two are alcohol possessing. Next one. Sulfur possessing amino acids. 14, 15. Yes, sir? Yes. 14, 15. Both are sulfur possessing. Now see this. This is CH2OH, serine. In the same way, if it is CH2SH. In the same way, if it is CH2SH. Can I call it as mercaptan? Thiols are called as mercaptans, right? So this is cysteine. Serine, cysteine. CYS, single letter symbol is C. If it is thioether, CH2, CH2, SCH3. If it is a thiol, cysteine. If it is a thioether, methionine. MET, single letter symbol, capital M, methionine. Now, benzene ring possessing groups. 16, 17. Remember as one set. So both are benzene ring possessing amino acids. Now observe alanine. Observe alanine. Remove one hydrogen, place benzene ring. Then it is called phenylalanine. Right? So alanine takes CH2 group and benzene ring. Then we call it as phenylalanine. Next, phenol. Place another OH group, same phenylalanine with phenolic OH. So CH2 OH. Right? So it is a tyrosine. TIR and Y, tyrosine. Now listen, sir. Benzene ring on reaction with concentrated H1O3, what do you get? Nitrobenzene. Right? With sulfuric acid and nitric acid mixture, then also you will get nitrobenzene. All proteins are made up of chain of these amino acids. That's why if accidentally nitric acid fall on your hand, your skin converts into yellow. Reason? Phenylalanine and tyrosine. Right? In that protein chain, phenylalanine and tyrosine will react with nitric acid to form nitrobenzene groups. Nitration will happen. Correct? OH is ortho para directing. So you will get OH groups at ortho position and para is blocked. Here, 3 times at ortho positions and at para position. Correct or not? So nitration will happen either here, here, and here. In this case, both happen at ortho positions. Right? Because of that nitration, your skin turns yellow. Clear? Why proteins react with nitric acid or why proteins turns yellow with nitric acid? Because of phenylalanine and tyrosine. Right, sir? Next one, sir. 18th one. These 3 amino acids, 18, 19, 20. Remember them individually. Tryptophan. Right? Possess indole functional group. Indole group means benzene ring, 6-member ring, and a 5-member ring with nitrogen. Right? It is called indole group. Benzene ring and a 5-member ring with nitrogen in it. I have a doubt here, sir. If you have a structure of this, once check whether that CH2 chain is here or here. I have a doubt in this. Tryptophan. Correct only, no? Right, not on adjacent to nitrogen, right? Means the structure is correct only, no? Right? So tryptophan. We call this group as indole. Right? So tryptophan have indole group. Tryptophan have indole group. Next, imidazole group. Imidazole means 5-member ring with 2 nitrogens. Then it is called imidazole. This also I have a doubt. Check, sir, whether that chain is at 2nd position or 4th position. This is called imidazole. Imidazole group. Check, sir, where it is that carbon chain. Carbon chain I want. Whether that carbon chain is here or here. Can I write that carbon chain here? Imidazole. Whether it is adjacent to lone pair possessing nitrogen or double bonded nitrogen. This is lone pair possessing nitrogen. Carbon chain is adjacent to it. Correct? Correct only, na? What is it? Histidine, na? So, no, man. Observe. Structure seems to be different. It is on double bonded nitrogen adjacent carbon. Wait. Lone pair nitrogen, okay. Here, lone pair nitrogen. It is not on adjacent of lone pair nitrogen. It is adjacent to double bonded nitrogen. Correct? Means this structure is wrong. So where I have to keep that chain? The chain must be here. Response, sir. Here it should be CH2 this. This is imidazole, right? Histidine. What is the use of this histidine? It is necessary for digestion, right? Histidine will trigger acids. Deleted. Right. Histidine will trigger secretion of acids from stomach walls. That's how we are able to digest food, right? If histidine triggers secretion of more acid, then acidity. Correct or not? If histidine, production of histidine itself is restricted, no acid secretion, you cannot digest food. Correct or not? So that's why when you are having any gastric problems or acidic problems, then you will take two different types of materials. One is antacids. What antacids do? Antacids, they will neutralize produced acid. One. Second, they will go and attack on the cell wall of your stomach cell wall such that secretion of acid is controlled. These are two types. Antihistamines are different. What are antihistamines? They will release the histamine, or they will go and attack on the site such that that cell will not detect this histamine. If histamine was not detected, the role of histamine failed. So it is also antihistamine. Correct or not? Or it will go and attack over that and it will remove histamine. Both are antihistamines. Respond. Right? If anything goes and attack over a cell wall and makes the structure of this, what we call that as prosthetic group, over an enzyme, if it attacks over one site, we call it as allosteric site. Right? If it is attacking over it, the structure of enzyme got changed. Right? That site is called allosteric site. Or if it go and attack over the active site, both are possible, no? Correct or not? In both cases, behavior got lost. Right. Okay, leave it. Histamine. HIS symbol is H. Now, 20th amino acid, sir. Observe the structure of it. This is the complete structure of proline. It is not R chain. It is the complete structure, right? NH, a 5-membered ring, COOH, and H. Is it alpha amino acid or not? And over this carbon, we have NH group, right? So till now, only 2 amino acids have secondary amine group. One is proline and another one arginine. But arginine have primary amine group also. Proline is the only amino acid which doesn't have primary amine group, right? Proline is the only amino acid which do not have primary amine. This is secondary amine group. This is the complete structure of proline. Respond. Any questions in it? Respond, sir.
No, sir.
All these structures are important. Again, sir, if we have, or this structure is fixed for all amino acids except one amino acid. This structure is fixed, correct? What is that only amino acid which doesn't have that structure fixed? That is, respond, sir. This is the complete structure of proline. It has only secondary amine, right? Cyclic secondary amine possessing group is proline. Except that remaining all have primary amine groups. If that R is hydrogen, glycine, single, only one non-optically active amino acid, not optically active. If that is methyl, alanine. If it is propyl, isopropyl, valine. If it is isobutyl, leucine. If it is secondary butyl, isoleucine. Right? Now, if it is having 3 carbons followed by an NH and a carbon double bond NH and NH2, arginine. Right? If you have 4 carbon chain and an NH2, lysine. Arginine, lysine, both are basic. If it is having 2 CH2 groups and COOH, glutamic acid, 1 CH2 and COH, correct? 1 CH2 COH, 2 CH2, 3 carbons, 2 CH2 and 1 COH, glutamic acid, 1 CH2 COH, aspartic acid. If it is amide groups, glutamine, asparagine. Easy to remember up to here, right? Next, alcoholic. If it is CH2OH, first bottom one, serine. Above that, if it is secondary alcohol, CH2OH, CHOH, CH3, secondary alcohol, then it is threonine. Both are serine and threonine are alcohol. In CH2OH, in serine, instead of OH, if I write SH, mercaptol. CH2SH, cysteine. If it is thioether, CH2, CH2, SCH3, methionine, thioether. Next, if it is having CH2 benzene ring, phenylalanine, and a OH group also, tyrosine, right? Next, almost over. Only 3 more left, right? Proline already over. Only 2 more left. Histidine and tryptophan. If it is having a benzene ring, adjacent to that a 5-membered ring with NH and 1 CH2 chain, right? What we call that group as indole group. If you have an indole group over that carbon chain, then it is called tryptophan. If it is an imidazole group, 2 N's and CH2 chain is not on adjacent to double bonded N, Histidine. Oh. Easy or not? All amino acids to remember. In them, essential amino acids are how many? 10? Response, sir. How many essential? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 essential. Remaining 10 are non-essential. Yes. Semi-essential. Semi. Right? Done, sir? We are done with amino acids. If these amino acids are connected to each other, then we call that bond formed between them is called peptide bond. It is nothing but amide only, right? CONH is called amide link. So when two amino acids connect, you will get an amide group. If both are amino acids, then only it is called peptide, right? Between amino acid and some other carbon chain with amide link, then I don't call it as peptide. It is called amide only, right? Are you able to understand? I am taking this as NH2, CH2, COH. What is this one? Is it amino acid or not? Alpha amino acid or not? Glycine. All peptides are amides, but all amides are not peptides, right? Now, if I take again NH2, CH2, COH, if I connect these two, what happened? From here, OH group, from here, H is lost, H2 is lost. Then you will get NH2, CH2, CO, NH. 8 is CH2, COH. Right? We call this bond as peptide. Right? If there is one peptide bond, I require two amino acids, then it is called dipeptide. So dipeptide means two amino acids forming one peptide bond. It is called dipeptide. Now tetrapeptide have how many amino acids? A tetrapeptide have how many amino acids? 4. But how many peptide bonds? 3. Is it clear? Pentapeptide means 4 peptide bonds, 5 amino acids. No confusion now? Response, sir. Do you have any questions in it?
Sir,
Yes, sir. Next, sir, regarding properties of amino acids. Regarding properties of amino acids. Properties of amino acids. Based upon their pH, when I dissolve them in water, what is the pH of solution generated? We call them as cationic or anionic or zwitterion. Based upon pH of the solution, amino acids will behave as cationic or anionic or zwitterion, right? If in amino acid NH2 group is there, COH group is there, both are there. If only COH group got ionized, NH2 remained as it is, then anionic. Correct or not? And only COH group got ionized. Then what happened to this chain? Anionic chain, no? Response, sir. Means I need to remove H plus. To remove H plus, what should be the pH of given solution? Basic. Correct? Response, sir. So based upon the given pH of the solution, from amino acid, either H plus will be gone or that NiH2 group may gain H plus to form NiH3 plus, or both may happen. If both exist, zwitterion. If only this exists, anionic. If only this exists, cationic. Is it clear? So based upon pH, amino acid exists in three forms: cationic, anionic, zwitterion. Cationic amino acids means they will migrate towards. They will migrate towards. Migrate towards cathode. Correct? Cations will migrate towards cathode or not? Cathode is negatively charged. Anionic amino acids, they will migrate towards. They will migrate towards anode. Now, what about zwitterion? They do not migrate. They do not migrate towards any electrode. Right? The pH at which zwitterion formation occurs, we call that pH as second step also. Attendance sheet. So it does not migrate towards any electrode. Now, the pH at which zwitterion formation occurs, we call that pH as isoelectric point. Now define what is isoelectric point. It is indicated by Pi. Now, what is isoelectric point? pH at which zwitterion formation occurs is called isoelectric point. Response, sir. Now, at isoelectric point, amino acids are least soluble in water. At isoelectric point, amino acids are least soluble in water. This is how we will separate amino acids. For example, if there is a protein, I have done hydrolysis, then that protein break down into many amino acids. Then how to separate those amino acids means I will keep on changing the pH. For a particular amino acid, this pH may become isoelectric point. Then immediately that protein, that amino acid settles down. Now I will change the pH to some other pH. Then another amino acid's isoelectric point will be this pH. Then that amino acid will precipitate. Is it clear? So at isoelectric point, amino acids are less soluble in water. This idea is used for separation of amino acids. Any questions in this? No. At isoelectric point, pKa1 plus pKa2 upon 2, where we saw this formula. Online students, where we have seen this formula, we derived it also, if you remember. In ionic equilibrium chapter, we derived it. Correct or not? Example. Sodium bicarbonate, NaHCO3. If I dissolve in water, it forms HCO3 minus, correct? What type of ion HCO3 minus is? It can give H plus or not? HCO3 can give H plus. It gives H plus and forms CO3 2 minus. At the same time, it can take H plus also to form H2CO3 and OH minus. It is capable of generating or it capable of giving H plus. It is capable of absorbing H plus. Therefore, what is HCO3 minus? Amphiprotic anionic hydrolysis. Or is it amphiprotic anion or not? It is showing hydrolysis. So that's why it is called amphiprotic anionic hydrolysis without cationic hydrolysis. In that case, pH becomes equal to pKa1 plus pKa2 by 2. Is it clear? Nothing but behaves like Twitter. Respond. Any questions in this? Online? Someone respond, sir.
No doubt, sir.
Next, I'm taking one example. Alanine. What is the structure of alanine, sir? What is the structure of alanine? Alanine. One methyl group should be there. So NH2. I'm taking one carbon. And here I am taking COOH. And here CH3. Now, at a particular pH, COH will ionize to form COO minus and H plus. That H plus will come here to form NH3 plus. Now what happened? It is having both cationic part as well as anionic part, right? Better let me write that also. Deuterion means both positive, comma, negative charges exist. Both positive and negative charge, both exist. Then it is called deuterion. Now, is it deuterion formation or not? No. Among these two, which gives H plus readily, right? So I am writing this also. Now, do both can give H plus ion or not? Or if it is NH4 plus and CO minus, then it is deuterion. Now, in this case, in this form, both gives H plus, right? Which gives H plus readily? NH3 plus, right? Now, H plus, if it gives readily, means what is its pKa value? Or if it gives H plus readily, Ka will be high, pKa will be low, right? So NH2 group having some pKa value or not? Do NH2 group have some pKa value or not? So its pKa1 is 9.69. Its pKa2 is 2.34. Right? Now what is isoelectric point Pi? And if its pKa1 is 9.69, NH2 is base. So its pKa value must be high. Correct or not? COH is acid. So its pKa value must be low. Correct? So what is Pi value? 9.69 plus 2.34 upon 2. So approximately 6.02 1 something. Right? Any questions, sir? Respond.
Sir.
In short, if you have many such groups, how to find isoelectric point means observe all pKa values. The pKa values which have less difference between them, take average of it. That is its isoelectric point. Are you able to understand? For example, let me take one more example. If amino acid have an ionizable side chain, if it has an ionizable side chain, then isoelectric point is average of pKa values for similar ionizing group. Similar ionizing group. For example, COOH, CH2, CH2, COOH, H, NH3 plus. What is this one, sir? R group is CH2, CH2, COOH. Aspartic acid. Correct or not? Right? No. pKa values. Here its pKa is glutamic acid. Glutamic acid. Hey, glutamic, correct. If it is 1CH2 COH, aspartic acid, right? Its pKa is 9.67. Here pKa is 2.19. And here pKa is 4.25. Now, what is isoelectric point? Three pKa values are there. If there are only two pKa values, no problem. If there are three pKa values, whichever are closer pKa values, take average of it. Read this statement. Similar ionizing group. Which are similar groups here? COH, COH. So take average of it. Is it clear? These two are closer values, correct? So pKa, Pi is equal to 2.19 plus 4.25 upon 2. So it is 6 point, this is a 3, sorry, 4 means 22, 3.22. Any questions? Response, sir. Do you have any questions?
No, sir.
No. Some additional information, sir. Yes, yes, yes. Go for break. Go. I will stop for 5 minutes. So go for break and come back. Right, almost we are at the end of amino acids. Right, then we will see structure of proteins. Already you know primary, secondary, tertiary. If all the amino acids form a long linear chain, then it is called primary structure. If it coils, secondary. If it coils further over it, tertiary. Right, if it further coils further and further, quaternary. Right, linear. Primary, if it coils, it may be coiling in the form of either alpha form or maybe plated, beta plated. Okay, alpha form, alpha helical structure. Then it is secondary. If it coils back on it, tertiary. If it coils further and further, quaternary. Right? What do you mean by denaturing of protein? If a quaternary, tertiary, secondary structures, that coiling was removed, that hydrogen bonds are broken, and if you form a linear chain, nature of protein is lost. We call it as a denaturing of protein. If the coiling is lost, denaturing of protein. That's all. All right. So anyhow, we will discuss that. Just go for break. Come back within 5 minutes. Right, sir. You stay back, online students. Join in the same link. Right. Remain in the same link. Right? Shall we continue with chemical properties or shall we solve any paper? Your choice.
Paper, sir.
On paper.
Paper.
So I think last class we are at the end of completing this paper, right? And one more paper is about this one. This is based upon class 11th portion. This is based upon your current portion, I think so, right? So let me complete this also. Up to 26, 27, 28, 29 over. Now come to 30th question. Which of the following statements are correct regarding halogens? All halogens are diatomic molecules at ordinary temperatures. No. Bromine is liquid. Iodine is solid. Fluorine, yellow. Greenish. Chlorine is greenish yellow. Bromine is brown liquid. Iodine is dark violet solid. So all are gases means the statement is wrong. Bromine dissolves in chloroform imparting blue color. No, it imparts. Chloroform is colorless. Bromine dissolves in chloroform or carbon tetrachloride forms brown color. So this is also wrong. Correct? Huh? Chlorine monoxide and means Cl2O. Chlorine monoxide Cl2O is evolved when KClO3 is treated with concentrated sulfuric acid. With concentrated sulfuric acid, what I have to do? Cation exchange. I have to write HClO3 plus KHSO4. Response, sir. It forms KHSO4 plus HClO3. From 2 molecules of HClO3, if I remove water, because concentrated sulfuric acid is a dehydrating agent. If I remove H2O, what you will get? Cl2O5. Correct or not? But not Cl2O. Say something. Means this is also wrong. Next. Chlorine sorry, chloride ions can be confirmed by chromyl chloride test. Yes, perfectly correct. What is chromyl chloride test, sir? Ionizable chlorides means whichever is readily soluble in water and convert into ions readily. NaCl, CaCl2, right? AlCl3, which are readily convertible into ions. And if that free Cl minus ions are available, those Cl minus ion species with K2Cr2O7 in presence of acid converts into CrO2Cl2. We call it as chromyl chloride, which is reddish colored vapors. This with NaOH converts into Na2CrO4, yellow color solution. This with lead acetate converts into PbCrO4, yellow PPT. Observation of these three colors confirms the presence of chloride ions. We call that as chromyl chloride test. Clear up? Let me show that chromyl chloride test. Very, very important test, sir. Let me show that chromyl chloride test one more time. Just a moment. Qualitative analysis. Oh, not there. PS batch, it will be there, I think so. Yes. It is not opening. But in lab, you will do this qualitative analysis, right? Class 12 laboratory, right? Laboratory test in which test for chlorides. Here. Chromyl chloride test. Just read. Ionizable or readily soluble chlorides with H2SO4 in presence of K2Cr2O7 gives deep red vapors, CrO2Cl2, which is called chromyl chloride. These vapors are passed through NaOH to get yellow solution. This solution with lead acetate gives yellow PPT. Confirms chromyl chloride. HgCl2, SnCl2, AgCl, PbCl2, SbCl3, all these will not give the test. Reason? They are not soluble in water. If they are not soluble in water, they will not give Cl minus ions. So those will fail, right? Whichever gives Cl minus ions readily, only they will give chromyl chloride test. Corresponding reactions. Cl minus or NaCl with H2SO4 forms NaHSO4 plus HCl. K2Cr2O7 and with H2SO4 forms CrO3. This CrO3 and HCl will combine to form CrO2Cl2. That CrO2Cl2 with NaOH forms Na2CrO4. That Na2CrO4 with lead acetate forms a PbCrO4. Chromyl chloride test. While you are doing this test, there should not be any moisture. This test should be carried out in dry test tube. Otherwise, CrO2Cl2 will undergo hydrolysis. That color fails. If color fails, chromyl chloride test fails. Any questions in it? Clear now about chromyl chloride? So answer is option 4. Clear? Come to next one. When phosphorus is heated with concentrated HNO3, it reduces. At concentrated, na? You will get NO2 gas. Correct? So P4 with concentrated HNO3, what you should get? You should get H3PO4 plus NO2 gas. Right? Let me show this reaction also. P block. Nitrogen family. See this? P4 with HNO3 forms H3PO4 plus NO2. SC8 with HNO3 H2SO4 plus NO2. Carbon CO2 NO2. Iodine HiO3 NO2. Observe. I2 gives HiO3. Carbon CO2. Sulfur H2SO4. Phosphorus H3PO4. Over. Right? So with HNO3 you got H3PO4 and NO2 gas. Next one. Heating ammonium dichromate. Ammonium dichromate, sir. What is this reaction? Ammonium dichromate. Orange colored crystals. Laboratory volcanic eruption reaction. We saw the video also. NH4 twice Cr2O7. Orange colored crystals on heating produces N2 gas. Any ammonium compound, if you have oxygen, what I have to do first? Remove water. How many water molecules I will remove? 4 to the 8 hydrogens, means 4 H2O I can remove. If a 4 H2O is removed, how many oxygens left? 3. So Cr2O3. As we are heating strongly, you will get nitrogen and water as steam. Right? These gases escape out. This is dark green color. Dark green almost seems to be black. Dark green color solid. So that will spread out as ash. Nitrogen and steam is evolving out. So it seems like volcanic eruption reaction. It doesn't look properly there. This is the color, right? Orange colored crystalline solids, right? Now he's heating it. So N2 gas and steam is evolving out. Cr2O3 is sprayed out. It looks like volcanic eruption, right? Done. I'm removing, closing it. Very, very important reaction, right? Now in this, nitrogen changing from -3 to 0. Chromium is changing from +6 to +6. Correct? Are oxidation state of chromium, man? It is Cr2O7 2-. So +6 converted to +6. Nitrogen converted from -3 to 0. Hydrogen remains same, oxygen also remains same. Everything is remaining same. So what is this reaction? -3 to 0. Oxidation. Correct or not? Any questions? Huh? What, sir? Here oxidation state of chromium is +3. Check. And it is Cr2O3 +3. So chromium converted from +6 to +3 means reduction. Nitrogen undergone oxidation. It is redox reaction. Both reduction and oxidation happen within the molecule. That's why it is called intramolecular redox. This year's NEET question. Intramolecular redox. What? Same reaction, man, they give. Intramolecular redox. If the same element undergoes both oxidation and reduction, Then is also intramolecular redox, but we call it as disproportionation. If same element from two different compounds undergone, then it is called conproportion. Right? Same element undergoes into different disproportionation, from different to same conproportionation. Within the molecule, one undergoing oxidation, one undergoing reduction. Then it's called intramolecular. So it is example of intramolecular redox. Now, magnesium nitrate with water, what you will get? Magnesium hydroxide plus ammonia. And nitrides form ammonia. Phosphides gives PH3. Arsenides gives ASH3. Correct? This is also ammonium compound. What I have to do on heating? What I told you? Any ammonium compound. First remove water. Remove water first. So 2H2O plus N2. Correct? Now, sodium peroxide with water. What do we get? Hydrogen peroxide plus NaOH. Now, what they are asking? It gives a gas. Which among the following also gives same gas? Right? If it is ammonium nitrate, this is ammonium nitrite. If it is ammonium nitrate on heating, what I have to get? First, I have to remove water. And then N2O. Right? You got nitrous oxide. So ammonium nitrate gives nitrous oxide. Ammonium nitrite gives nitrogen gas. Ammonium dichromate also gives nitrogen gas. Respond. Any questions in it? Next. Select the correct statement among the following. About P4O10. What is P4 molecule? Tetrahedral, correct? Discrete tetrahedral molecule, P4. Right? Now, P4O6 means place oxygen between P and P bonds. Then it is called P4O6. Do it have 6 oxygens or not? So this is P4O6. On every phosphorus, place one more oxygen. Then it is P4O10. Done. P4, P4O6, P4O10. Right? P4O10, or we can also write as P2O5, phosphorus pentoxide. P2O5, dimer is P4O10. Good dehydrating agent. Correct? Reacts with water readily to form phosphoric acid, H3PO4. Right. Now coming to this. First, check option 2. All the phosphorus atoms are sp3d hybridized. So all the phosphorus are sp3d hybridized or sp3 hybridized? sp3 hybridized, na? What is the shape around phosphorus? Around phosphorus, what is the shape? Tetrahedral. So every phosphorus is sp3 hybridized. So then what is that pi bond? That pi bond is between d orbital of phosphorus and p orbital of oxygen. So this is p pi d pi bond. Right? Now, there are 10 POP linkages. No, only 6. POP links are 6. Total number of sp3 hybridized atoms per molecule is 10. Totally 10 sp3 hybridized atoms are there. 4 phosphorus. Every oxygen is sp3 hybridized. No? Every oxygen have 2 lone pairs and 2 bonds. So every oxygen is sp3 hybridized. So totally 6 oxygens and 4 phosphorus. Totally 10. They want correct statement. Right? This will react with water to form H3PO4. Means this is anhydride of H3PO4, not H3PO4. Correct? All phosphorus atoms are sp3 hybridized. There are 6 POP bonds, and option 4 is correct. Clear? Next, sir. Among the following, which of the compound of sulfur has peroxide linkage? Waste question. What is this? Marshall's acid. H2S2O8. Marshall's acid. Correct? What about H2S2O6? Yesterday's class we have seen H2S2O5, O4, H2S2O5, H2S2O6. These three possess S bond. Correct? So this is nothing but H2S2O6 only. So what is its structure? It is a H2S2O6. Now H2S2O7. Place one more oxygen in between. Place one more oxygen in between. Now H2S2O3. S double bond S, double bond O, OH, OH. H2S2O3. Thiosulfuric acid. If it is Na2S2O3, then it is called hypo. For developing black and white photographic films, use hypo solution. Question number 37. You have to answer. D and F block. Which of the following oxide of vanadium is amphoteric? All oxides of vanadium are basic, except V2O5. V2O5 is distinctly acidic or amphoteric. Slightly acidic but amphoteric. Correct or not? So V2O5. Acidic oxides only 3. Or in your textbook also they have given 3. V2O5, CR2O3, sorry, CrO3, CrO3, Mn2O7. Correct? In which they mentioned this as slightly acidic, but it is amphoteric. Only these 3 are given na? Under acidic. So answer is C only. Observe the statements and choose the correct option. KMnO4 oxidizes nitrite to nitrate. Yes, oxidizing agent. Nitrite means NO2. Nitrate means NO3. Right? Sulfides to sulfate. Sulfite to sulfate. Nitrite to nitrate. Arsenite to arsenate. Correct or not? So ites will convert to eights. So this is correct statement. Manganous salt. Manganous salt. Manganous salt means Mn plus 2. Why they are taking Mn plus 2? Is oxidized to MnO2. Okay, let us check. So they are saying Mn plus 2 salt and MnO2. No. And KMnO4. KMnO4 means MnO4 minus in presence of Zn plus 2. Yes, correct only. Correct only. It is direct bit. I think it is there in your target booklet also. Just a moment. Observe, sir. Very important. Can't proportionation reaction example. Manganese is in plus 7 state, KMnO4 and Mn plus 2. Both will convert into MnO2 in presence of zinc Zn plus 2 or zinc oxide or zinc sulfate as a intermediate. Catalyst. Right? This reaction they have done. Right? So this is correct. So both statements are Statement 1 and statement 2, both are correct. Statement 1 and statement 2, both are correct. Next one. In which of the following chlorine is produced using atmospheric oxygen? Oh, Deacon's process. What is it? HCl reacts with atmospheric oxygen in presence of cuprous chloride, no? Cu2Cl2, right? To form H2O plus Cl2. We call that as a Deacon's process. Next one. Match the transition metal ions in column 1 with color of aquated color of D block. We have one table in NCRT with the color of ions, right? Zn plus 2, colorless, because no unpaid electrons. So A is 3. A is 3, means this is gone, this is gone. So A is 3 is correct. No need to check for C. C is 1. So C is 1 means Fe plus 2 green, that also no. Vanadium plus 2. Chromium plus, I think vanadium plus 2 violet is correct, I think so. Chromium plus 2 blue. Yes, correct, I think so. Right? So B2 D4, I think so, option 4. Just a moment. Why it is not opening? Here, sir. Vanadium plus 2. They gave chromium plus 2, not chromium plus 3. If it is chromium plus 3, violet. So vanadium plus 2, chromium plus 3, manganese plus 3. These three are violet. Vanadium plus 2, chromium plus 3, manganese plus 3. Observe vanadium plus 3, green. Vanadium plus 2, violet. Vanadium plus 4, blue. Right? So you need to remember those two. So vanadium plus 2, chromium plus 3, manganese plus 3 are violet. Already you know, cobalt, copper, both you know, blue. Chromium plus 2, vanadium plus 4, blue. Vanadium plus 3, iron plus 2, nickel plus 2, green. Only one, titanium plus 3, purple. Fe plus 3, yellow. This is known. Cobalt and manganese plus 2, pink. This is also known. Colorless waste things. Right? Only you need to remember these three. Right? Vanadium plus 2, chromium plus 3, manganese plus 3. These three are violet. Vanadium plus 3, iron plus 2, nickel plus 2, green. Vanadium plus 4, copper plus 2, cobalt plus 2, chromium plus 2, blue. Right? Cobalt plus 3, blue. Cobalt plus 2 is pink. Cobalt plus 3 is blue. Done? So answer is option 4, correct now? Next. In which of the following MOM linkage is not present? MOM, central atom, okay. Not present. P4O10, it is present. This one. Just now we have seen. SS bond is there. Next. Which of the following is the strongest oxidizing agent? HClO. It readily decomposes to form HCl plus nascent oxygen. Correct? Which of the following is an anhydride of perchloric acid? Perchloric acid means HClO4. Anhydride means take 2 molecules, remove water. If I remove water, what will you get? Cl2O7. Correct? Anhydride. Next one. Over. Right? We are done with this paper. Next, sir. In this paper, which questions you want me to solve? Chemical bonding or periodic classification or structure of atom or mole concept? Whichever you say, I will solve. Periodic classification, huh? Your choice, man. Whatever topic you say, I will solve that. Online. Anyone alive?
Yes, sir.
Yes, sir.
Just try to recall the concept, sir. Definitely 12th students might have forgot everything, right? Just try to recall by solving it. If you are unable to recall, refer and recall. All RM, PYM, OYM, FS, all students' papers related to these first 4 chapters I kept. For example, this is class 11 students' paper. The above paper is PYM students' paper, class 11th students' paper. Above that, this is also TYM. This is PC test series, your paper. Huh? This is RM phase 2 FT paper. This is also RM phase 2 paper. All different papers, but all related to first 4 chapters. So that's why I kept all these things at one place. Around 100, 110, 120 questions will be there. So by solving them, you try to recall. Question number 50. Actually, organic chemistry question. Quantitative analysis of an organic compound X contains carbon, hydrogen, oxygen, chlorine, shows following percentage composition. Empirical formula is waste question. And they give percentages. We need to find empirical formula. What you need to do first? Yes. So carbon, chlorine, hydrogen. 14.5 by 12. 64.46 divided by 35.5. 1.8 by 1. Do this total equal to 100 or not? 64.5, 14.5. 79. 79 plus 1.8. 81. Close to. Right? So oxygen is 9.2. 9 point what? 10.1. 14.5. 64.46. 1.8. All put together. 6. 8 plus 4. 12. 12 plus 5. 17. 17. 8. 9. 10. 6, 7, 8. 80 point. Wait. 80.76 only. $60, 70, 80. So it is 19.24 divided by 16. Correct, sir? Now 12, 1 point something. 12 ones are 12. How much left? 2.5. So 12 twos are 24. So approximately 1.2. This one. Approximately 1.8. 1.8. 1.16 gone means 4. Wow, approximately 1.2. Right? Yes, sir. Divide all of them with 0.6. Or we need to divide all of them with smallest value. Divide with 1.2. So this becomes 1. 1.8 by 18 by 12. 6
Sir,
2s
the
are
answer
6 3s are
160.
3 by 2. 3 by 2. 1. Multiply all of them with 2. So 2, 3, 3, 2. So C2, correct, H3, O2, Cl3. Now mass. Oh, they want empirical formula, na? Correct only. Empirical formula is correct. Right. So 35 into 3. Are 71, 35.5.
0.5.
This is 32, 3, 24. 0.5, 7, 8, 9, 10, 15, 6, sorry, 7, 14, 16, 165.5. Right? Into 10 power minus 1 means 1655 into 10 power minus 1. Response, sir. Next, question number 49. Solution is prepared by dissolving urea in water. If mole fraction of water is 0.8 in the solution, ratio of mass of urea to that of water is. We need to find mass ratio, right? Mole fraction is given as 0.8. Mole fraction of water is 0.8 means urea is 0.2. Means number of moles of water by number of moles of urea is equal to 0.8 by 0.2. Correct? Number of moles ratio. Mole fraction ratio is nothing but number of moles ratio. Number of moles can be written as weight by molecular weight. Correct, sir? And I can take number of moles of H2 as 0.8, number of moles of urea is 0.2, na? 0.8x, 0.2x. Correct? So number of moles into 18 gives mass, into 60 gives mass. What they want? Ratio of mass of urea to that of water. So I have to take urea on the top, water on the below. So 0.2 into 60 upon 0.8 into 18. Correct, sir? Respond. Over. How many times? 4 times, sir? 0.2 4 times. 6 tens are 6 3s are. So 10 upon 12. They want 10 upon x. X value. 12. Another waste question. Right? Next, sir. 48. In ground state electronic configuration of copper, number of electrons with zero orbital angular moment. Orbital angular moment is 0 means. What is orbital angular momentum? Root of L into L plus 1. Correct? H cross. This is orbital angular moment. If they say Z component, Lz equal to root of L into L plus 1 into H cross into cos theta. If they say Z component, I will write into cos theta, right? They gave this value 0. This value 0 means L equal to 0 means S orbital. So 1s2, 2s2, 2p6, 3s2, 3p6, 4s1, 3d10. So how many? 7? Number of electrons with 0, 7. Next, sir, 47. Okay, I will stop. 8:36. Already people are leaving. Okay. Right, sir. I will stop the discussion. Already half of them left. Right, sir. I will stop the discussion. Tomorrow also chemistry only. First lecture we will discuss biomolecules. Another lecture we will solve numericals. H cross into cos theta. We call it as Z component of orbital angular moment. Z component of orbital angular moment. We will take Z axis as reference axis, na? Right? That's why for all PZ M value we will take 0 because we are taking Z axis as reference axis. Right, sir? I will end the session, sir. Bye, sir. Good night.